And there we go. Okay, so now we're recording. So once again, for the third time, good morning, everyone. It's now at 11 o'clock, so we can get started. So once again, the last homework that we were talking about was absolute values, but with equations now, right? So we briefly talked about absolute values at the beginning of this course, like, going way back to the first week. We saw how they operate. They basically make any negative number positive, and any positive number just remains unchanged. Well, when they're inside of an equation, we don't necessarily know what is inside the absolute value if we have an unknown in there, right? So we're not 100% certain what's going on with that. So we have to follow a specific procedure on how to solve for that. So whether it's positive or negative, and we saw that essentially what we do is we fix one specific side, and then we go ahead and we start solving for the two other cases. So that's going to be your procedure for basically almost every single one of these questions. I think there's only one in particular that is going to be slightly different, and I'm sure that one will come up. So which questions do you guys have for me? What can we go over together? Number 25. Sure, 25 is the one special one that does not abide to those rules. So perfect. We're going to see that in just a second here. So let's look at 25 together. So 25 is 2 times the absolute value of 3x minus 4. And this is plus 9 equal to 7. Okay, so the game plan is still pretty much the same, right? Without me telling you that this was a quote-unquote special case, your game plan would be the same thing as it would be with all other absolute values. You would try to isolate for your absolute value. Once you've isolated your absolute value, you split it into cases, right? First you have the positive case, and then you have the negative case, right? And then you just go ahead and you solve both from there. So that's what we're going to do, right? So we're going to start isolating for our absolute value. So in this case, what does that mean? Well, we have 2 times our absolute value, and we have an addition tied to it, right? So much like if this were just a linear equation where you could think about, instead of it being an absolute value of some junk in there, you can just think about it of like 2x plus 9, right? And how would you solve for x there? Well, you would subtract 9 first, and then divide out the 2, and then you would go about your process, right? So that's exactly what we're going to do. We're going to subtract 9, and subtracting 9 gives us 2 times the absolute value of 3x minus 4, and 7 minus 9 gives us a negative 2. Okay, so we have a negative 2 now. And now, once again, we have a multiplication tied to our absolute value. So to undo multiplication, we're going to divide, and we're going to divide by 2, right? Because that'll undo the multiple of 2. So dividing both sides by 2, we're left with 3x minus 4 inside the absolute values. And this is equal to negative 2 divided by 2, which is just negative 1. So I imagine that if you guys understood the lecture, you guys probably got to this point and then you either hit a brick wall or you tried doing the cases and you saw that it won't work, right? Well, let's just think about this logically. What is the absolute value going to do? No matter what number is in there, right? No matter what the outcome, the absolute value is always going to make it positive or at lowest 0, right? If 3x minus 4 just happens to come out to be 0, then we would get a 0 inside the absolute value. The absolute value of 0 is still 0. So at lowest, it would be 0, right? And then once again, any other number that you plug in for x, be it positive or negative, is still going to come out to be positive because of the absolute value, right? That's what we know about it. So is there any way that we could ever get a negative number from an absolute value? No, right? There's no possible way we could ever get a negative number. There is no way that the absolute value of 3x minus 4 would ever be negative 1 or negative 2 or negative 3 or any negative number for that matter, because once again, the absolute value is always going to make it positive. So if you got to this point here, you could just jump to this and say there's no solutions. Because logically, you could just assume that there's not going to be any solutions, because once again, this negative sign is the key. How could an absolute value ever be less than 0? So that's one way that you could have approached it. The other way that you could have approached it is you could have actually tried to do the cases, right? So case 1 is where it stays positive, case 2 is where it's negative, and then you do the checks and you see that neither of the cases work and you still end up with no solution. So either way, no matter how you went about it, whether you actually did go through the, all of the steps, you would find out that there's no solutions. And then if you just got to this spot here where I just stopped writing, the absolute value of 3x minus 4 is equal to -1. Well, it doesn't matter that it's a -1. It could have been any negative number, and we would still end up with no solutions because, once again, absolute value on the left side is always going to be a positive number, right? So a positive number is never going to equal a negative number, hence there's no way that we're going to have solutions for this. So this was really the only tricky one, and this is the only one that I didn't really necessarily talk about on the lecture just because I kind of wanted to throw you guys a curveball on the homework, but this was the only one that was like that. Does anybody have questions on that and why the answer to this is no solutions? Again, I think that once you talk about it, once you talk through it, it makes a little bit more sense, realizing that, oh yeah, this side is guaranteed to be a positive and this side is guaranteed to be a negative. So how could a positive number be a negative number? But, obviously when you're staring this in the face, you might not see that immediately, and you might be tempted to try the cases. But even if you do that, it would still show that there's no solutions. Yes, Zenaida.
Did you subtract the 2 from the left and from the right?
I divided the 2, so it's 2 times the absolute value of 3x minus 4. So we started with a -2 on the right, we divided both sides by 2, and we had a -1 on the right.
Okay, but thank you.
Yep. Any other questions regarding this? Yes, Deborah.
I'm just asking, if you were to do the cases, aren't you supposed to plug in the x values in the original thing to absolute value 3x minus 4 plus 9 equals 7?
You're talking about plugging in your cases into here?
Yeah, because that's what in the lecture.
Yeah, so it should come out to be the same, though, because the operations that we made, you'd agree, are logical operations, right? All I did was I subtracted 9. The reason that I say you want to plug into your original is because plugging into your original ensures that there's no possibility that you made any mistakes, right? Like if you say, for example, you tried subtracting 9 from both sides and then you ended up with, I don't know, like you really messed up, hypothetically. You subtracted 9 from 7 and you got 16 somehow, right? If you plugged into the second equation where you made a mistake, you actually might be tempted to say, oh, no, I actually did get the correct solutions. But if your equation is incorrect, then your solutions are also going to be incorrect.
Okay.
Does that make sense?
Yeah.
Okay, cool. Okay. Any other questions on this one? Again, I know this one was a little bit tricky, so I really want to make sure everybody understands the real main reason that there's no solutions is because absolute value is always going to make this either positive or 0, and the right-hand side was negative. So there's no way this is ever going to come out. Okay, so I'm going to go ahead and assume we're all good with that. So Keji is asking for question 40. Sure, we can jump to 40. Let's clear this off. Okay, so number 40, we are starting with the absolute value of 3x minus 4, and this is equal to 2 times x minus 1. Okay, so you could, in theory, it doesn't really matter which way you do this. You could either distribute the 2 first, or you could split this into cases first. Either way, it really won't matter as long as you just distribute the negative properly when you do your negative case. So remember, it's the same exact procedure, right? We only have one absolute value in this case. So what we do is we fix the side that has the absolute value and we make that positive always, right? So in both cases, it's just going to remain 3x minus 4. And then the right-hand side for one case is going to remain positive. And then the other case, it's going to be negative, right? So let's go ahead and do the positive case first. So case 1, positive. Right? Okay, so we're starting with 3x minus 4. And remember, once you get to your cases, you can omit the absolute values, right? That's the whole game plan. That's why we have 2 cases. So we have 3x minus 4 is equal to 2 times x minus 1. And with this, again, we keep the right side positive because this is the positive case, right? So it just stays as 2 times x minus 1. So now we have 3x minus 4. and we distribute the 2. So we have 2 times x, which is 2x, and 2 times -1, which is -2. Okay, so now all we have to do is we just have to solve for a variable, right? This is a linear equation. It's x to the first power. There's no quadratics going on. We just solve for x. So to do that, we're going to subtract 2x from both sides because I have a 3x on one, a 2x on the other. I always want to move my x's over to just one side. So I'm subtracting 2x from both sides. We're left with x minus 4 is equal to -2. And last but not least, to add 4 to both sides, we get x is equal to 2. Everybody okay with just this first case before I move on? And we'll even go ahead and do a quick check because we want to make sure that this really is a solution, right? So check x is equal to 2. And checking for x is equal to 2, we get the absolute value of 3 times 2 minus 4. Oop, that was supposed to be an absolute value. And this is equal to 2 times 2 minus 1. Okay, so 3 times 2 is 6 minus 4 is absolute value of 2. So we get the absolute value of 2 in there. And then we get 2 minus 1, which is 1, times 2, which is still 2. And the absolute value of 2 is in fact positive 2 is equal to positive 2. So yeah, x equals 2 is in fact a solution. So great, that's one of our solutions, or maybe even the only solution that we have. We haven't done the other case yet. Everybody good with this one so far? Okay. So moving on to case 2, where we're going to test the negative. So testing the -1, we are going to write 3x minus 4 is equal to, and now this is kind of where I was saying it doesn't really matter if you distribute the 2 first or if you do the case as well, because if you do the case, it's going to be the negative of 2 and then just the whole thing again, right? So 2 and then inside these parentheses, x minus 1. That's it. So all you're going to do is you're going to distribute the 2 anyway, and then you're going to distribute the negative when you're done distributing the 2. So distributing the 2, we get 3x minus 4 once again. We have the negative on the outside. We get the same thing that we got before, right? 2x minus 2. But it's going to be the negative version of that, right? So we're going to negate that as well. We keep 3x minus 4, and now we get negative 2x plus 2, right? The negative applies to both terms inside of the parentheses, so it changes the sign of the positive 2x to a negative 2x. It changes the sign of the negative 2 to a positive 2. Okay, and now we just go through the same exact procedure that we did before, right? This is still a linear equation. We just want to move our x's to one side and then solve for x. So we have a negative 2x, so I just want to add 2x to both sides. So adding 2x to 3x, we get 5x minus 4. We added 2x, so the negative 2x goes away, and this is equal to 2. And now we want to isolate for our variable x, right? So since we have 5x minus 4, I'm going to add 4 to both sides. We have 5x is equal to 6, and dividing by 5, x is equal to 6/5. And that's it. That's all it is. Okay, so once again, we can do another check here just to make sure that 6/5 really is correct, right? And what was our original equation? 3x minus 4 inside the absolute value, and then 2 times x minus 1. So we have 3 times 6/5. I already forgot, minus 4. Yeah, my memory is just not the strongest these days. It's okay. So 3 times 6/5 minus 4 is equal to 2 times 6/5 minus 1, right? Okay. Does anybody want to volunteer to help me with fractions? I know it's everybody's favorite thing to do, but I would love somebody to help me with this. Sure, Zenaida. Okay. Yes. Help me out, Zenaida. Sorry, Zenaida, I didn't mean to talk over you, but yep, you're clear to go.
Cool. So how I did was just I just multiplied. I just did like 3/1, multiplied it across.
Sure.
So 18/5, take away 4.
Great. And then for the right side?
For the right side, 2/1, so it would be 12/5, and then 2/1 would just be 2, -2.
Perfect. -2. Great. Okay, you got us started. Thank you. And now, Jack, I know that you spoke up as well. So, Jack, help me out. How do I convert 4 to be in terms of fifths? So that way we can do all this subtraction and stuff.
Put a 5 in the bottom of it.
Put a 5 in the bottom of it. Great. And then what do we do when we put a 5 in the bottom of 4? Because we have to change the appearance, but not the value, right?
So you would put a negative 20 on the top?
Perfect. So I'm just going to put the minus out front, but yeah, absolutely. You're right. So 20 is up top over 5. Great. And it's the absolute value of that. And now do the same thing, 12 over 5 here. And what do I do for the 2?
You'd multiply it by 5.
By 5 over 5, right? So what's my top going to be?
10.
Perfect. 10 fifths. Great job. Okay, so now we just have to go ahead and simplify this, and I could just roll through this now. You guys were awesome. So 18 fifths minus 20 fifths, we keep the denominator the same, so that means we just subtract the numerators, and that is going to give us negative 2 over 5 inside the absolute value. And then over here, same thing, right? We're just going to subtract the numerators, and so that's basically 12 minus 10, which is 2, same denominator, over 5. And now absolute value of negative 2 fifths is positive 2 fifths. So positive 2 fifths is equal to 2 fifths. Hooray! This one also works out. So we have just shown that 6 over 5 is in fact a solution. So we have 2 solutions, and you would just write your solution set as x is equal to, God, what was the first one? 2? 2, yeah. So 6 over 5, comma, 2, and that's it. Anybody have questions on this before we move forward to a different problem? Again, I just want to verify everybody's all good with this. It's the same procedure that we do for 99% of absolute values, right? So that's 3x minus 4. We started with absolute value of 3x minus 4 is equal to 2 times x minus 1. It doesn't really matter what the right-hand side is. We're going to follow the same procedure, right? Since our absolute value is already isolated, we split it into cases where the absolute value side is always positive, and the right side is positive in one case and negative in the other. And then we just solve for our solutions. I imagine that it's not horrible, but, you know, I want to make sure that we're all good with that. Okay, so what other questions do you have for me? I know that there was one with a quadratic, but it wasn't really that bad because it wasn't, you know, the worst quadratic that it could have been. And also you really, you know, limited the cases. 37, sure, we can do 37. Okay, so 37, we have the absolute value of 3x minus 2. And this is going to be equal to absolute value of 6x plus 7. Okay, so remember what I told you guys when in the lecture, right? If you have an absolute value on both sides, it really won't matter which one you pick, because I did an example where we went through it twice, and the first time we kept the left side positive, and then we had our 2 cases for the right side, and then the second time we went through it, we flipped it, right? So we kept the right side positive, and then we had our 2 cases for the left side, right? So just because I have no intention of dealing with plus or minus 6x, I'm actually going to just keep 6x plus 7 positive. Is everybody okay with that? So that means I'm keeping the right side positive, and I'll have my 2 cases for the left. And once again, it really won't matter the way I'm doing it versus the way that you might have done it, where if you guys kept 3x minus 2 positive, that's totally fine. And then you would have had your cases for 6x plus 7, right? So either way, it would have been totally fine. I just want to make sure that we understand that. Okay. So let's go ahead and move forward with this. So with that in mind, again, I'm going to keep 6x plus 7 the same. So that means case 1, where we're doing the positive values, I am going to have 6x plus 7 to be positive always is equal to 3x minus 2. And 3x minus 2, because this is case 1, it's the positive case, we just keep it as 3x minus 2. So now all we have to do is just solve for x, right? So we subtract 3x from both sides. So subtracting 3x, we're left with 3x plus 7 is equal to negative 2. We're going to subtract 7 from both sides. So subtracting 7, we get 3x is equal to negative 9, right? Negative 2 is already a negative number. We're taking 7 away from a negative number. It becomes a bigger negative number, so negative 9. And now we're just going to divide 3 from both sides, and we end up with x is equal to negative 3, right? So all we did was, again, we just kept 3x minus 2 positive, and we solved for x. And this would be the exact same thing that you would get if you chose the other side to keep positive, if you kept 3x minus 2 positive, and then if you negated, or I'm sorry, if you kept 6x plus 7 positive, because 6x plus 7 positive is still 6x plus 7, right? So you would end up with the same solution of x is equal to negative 3. So now we have to do case 2. So case 2, where we're dealing with the negation, right? So we keep 6x plus 7 positive, and now it's the negative version of 3x minus 2. So what does this do? Again, the negative is going to apply to both the 3x and as well to the negative 2. So we have 6x plus 7 unchanging, and this becomes negative 3x plus 2, right? The negative makes the positive 3x a negative, and it makes the negative 2 a positive 2. So now what we have to do is, once again, we solve for our variable. So I'm going to add 3x to both sides. We are left with 9x plus 7 over here. The 3x's cancel, and we're left with 2 over here. And we're going to subtract 7 from both sides. So subtracting 7, we're left with 9x is equal to 2 minus 7 is negative 5. And dividing by 9, we get x is equal to negative 5/9. And it would be good if we check our solutions, right? So we had x is equal to negative 3 first. We had x is equal to negative 5/9. So let's go ahead and try to check these solutions. So plugging them into our original, we have absolute value of 3 times negative 3 minus 2 is equal to the absolute value of 6 times negative 3 plus 7. Okay, so rolling through this, 3 times negative 3 is a negative 9 minus 2, right? So negative 9 minus 2 is a negative 11. So we have negative 11 here. And then on the right-hand side, 6 times negative 3 gives us a negative 18. And negative 18 plus 7 is going to give us a negative 11. Well, hooray. We already know this is going to work, right? We have the same thing on the left as we do on the right. And so absolute value of negative 11 on both sides just gives us 11 is equal to 11. Yay, this one works, right? So x is equal to negative 3 is in fact a solution. We can check that one off, and that will be part of our solution set. And now we just have to do the same thing, but for negative 5/9, which albeit pretty gross, right? Not something that we all want to do, but, you know, doesn't hurt to do it. So check for x is equal to negative 5/9. And doing this, we know that we're going to have the absolute value of 3 times negative 5/9. And this is going to be minus, I never remember, minus 2. Perfect. And then on the other side, the absolute value of 6 times negative 5/9. Plus 7, I believe, right? Plus 7. Okay. So we have to go ahead and do the same thing that we did for the previous example, where we have, fraction multiplication and subtraction. And unfortunately, that's just life sometimes. So we have 3 times negative 5/9. Well, Zenaida already pointed out to us earlier that basically what that means is we're just taking our 3 and multiplying that against our numerator, right? So we have the absolute value of negative 15 over 9 minus 2. And then on this side, we have, again, same thing. We're just going to multiply the numerator, right? So we get the absolute value of 6 times negative 5, which is negative 30 over 9 plus 7. Okay, now before we do any common denominators, I'm going to pick on somebody here to help me simplify a little bit, because we can, in fact, simplify these fractions to be a little bit nicer. So, Olivia, help me out. Help me simplify my fractions so that way we don't have to deal with a negative 30 over 9, because that seems pretty daunting, right? We don't want to deal with that. Same thing with the negative 15 over 9.
Okay. Can I just type it? It hurts to talk.
I'm sorry?
Can I type it? It hurts to talk. I got my wisdom teeth out.
Yeah, sure. Yep, I totally forgot. That's my fault. Sorry about that. Yeah. Feel free to type this one out if it's easier for you to type. So again, the idea here is we just want to simplify our fractions. We want to get, after that, we'll get common denominators for our -2 and our 7. We'll combine the fractions when we're all said and done. And then hopefully the same thing will be on the left as it is on the right. And then we'll have proved that -5/9 is in fact the solution, right? So all I'm asking Olivia to do right now is just help us simplify the fractions, because we can simplify them, right? And it's a lot better to simplify now than try to find a common denominator for -2 and 7 being in terms of ninths, because it's just going to get really messy really quickly, right? And we don't like messy. Messy gets complicated. So Olivia, I'll give you like another 10, 15 seconds just to see. I totally forgot about the situation. -5/3 -2. Yeah, exactly, right? So essentially what we're going to do is we're going to cancel a factor of 3 from the top and bottom of both fractions, right? We see that a 3 goes into 9 and it goes into 15, and then 3 goes into 9 and it goes into 30 as well, right? So we can cancel a factor of 3, and canceling a factor of 3 from the top and bottom of both fractions gives us exactly what Olivia wrote, -5/3 -2 inside the absolute values, is equal to, and sorry, that's supposed to be an absolute value, not a 1, is equal to, and then once again, -10/3, so -10/3 plus 7. Okay, cool. So now what we're going to do is, now that we simplified fractions, it's in terms of thirds now, we don't have to deal with in terms of ninths. We're going to go ahead and make common denominators for our 2 and for our 7, or well, our -2 and 7, and then we'll combine fractions and move on from there, right? So doing so, we are left with -5/3 minus, well, I want it to be in terms of thirds, right? So I'm going to multiply the top and bottom of 2/1 by 3. So we're going to get 6/3 here is equal to -10/3 and then plus 7, but I need it to be in terms of thirds as well. So in terms of thirds, we're going to have plus 21/3, right? Multiplying the denominator of 7, which is just 1, by 3, we get a 3, and then multiplying 7 by 3, we get 21. So now we have all of our stuff in terms of common denominators. We can just go ahead and subtract, right? Because now we have common denominators, we can subtract or add the numerators. So keeping the absolute values, we have -5 minus 6, which should give us a -11/3. And for this side, we have -10 plus 21, which will give us a +11/3. And we already know that positive, negative doesn't matter when it's inside the absolute values. We're going to get the same thing, which is the +11/3. So +11/3 here, +11/3 here. In fact, this is a solution. So we have now shown that both the possible solutions that we got, x is equal to -3 and x is equal to -5/9, are correct. So we would just write our solution set. -3, -5/9, and we're done. Anybody have questions, again, on the process? The process should be pretty similar. All we did was we chose one side to remain fixed. So the way I did it was I chose 6x plus 7 to remain fixed. If you chose 3x minus 2 to remain fixed, that's totally fine as well, because you have that liberty when you have absolute values on both sides of an equation. So I chose 6x plus 7 to remain fixed, so that's why we have a positive 3x minus 2, and then we have a negative 3x minus 2. I solved for the variable twice. We got x is equal to -3, and then x is equal to -5/9. And by doing our checks, we showed that, yep, both of them do work. So both of them are solutions, and we have our final solution set. Any questions on this? Don't be shy, remember. Asking any questions in general is going to help your participation score, I promise you. And if there are no questions on this, then we can just move on to a different question on the homework. Okay, so there's no questions. So the only one that I want to go over in particular is question 29. And the reason I just want to go over 29 is because although it's a quadratic, and it might look scary because I did that whole big example at the end of the lecture with a quadratic, and it ended up in 2 cases, which was 4 solutions because it was a quadratic, 2 solutions per case. We see that because it's actually equal to 0, we don't have 2 cases. So let's go ahead and try that one. So that number is 29, and we're starting with the absolute value of x squared minus 4 is equal to 0, right? So once again, under normal circumstances, if you had any positive number, so any number that wasn't 0, and again, assuming it's not negative, because if it were negative, we know that we would have no solutions, as we talked about at the beginning of this lecture with number 25. We know that we would split it up into cases, but because it's 0, case 1 is positive 0, and case 2 is negative 0, so it's really the same case either way, right? So we actually just need to drop the absolute values and then solve for this, because if it's the same case either way, we only have one case. So we drop our absolute values and we say, okay, well, it's really just x squared minus 4 is equal to 0. And x squared minus 4, well, help me solve this. Anybody. It's a quadratic, right? And you could solve this in a couple different ways. You know, be a difference of squares, considering the square root method, quadratic formula. I'll take anything. So let's see here.
I did the problem by grouping.
You did it by grouping.
Factored by grouping.
Okay, sure. So you want to run me through how you did that?
Yeah, so I broke it up into x plus 2, x minus 2 equals 0.
X plus 2 and x minus 2 is equal to 0. Okay, well, this is, in fact, difference of squares, right? Because you have a square. 4 is really the same as 2 squared, right? So you have a square again, and you have difference of squares. So then you would get a plus b, a minus b, right? And in this case, a is x, b is 2, so x plus 2, and then x minus 2, which is exactly what you wrote, right? So just careful on your wording, because grouping is where like you split up your middle term, and then you would have essentially 4 terms. You would group them in terms of pairs, and you would pull out the largest factor that you can from each parentheses. This one is straight up just factoring, and it's by our special case, which is difference of squares. But I'm glad that you were able to remember that nonetheless. So difference of squares. So we got x plus 2 times x minus 2 is equal to 0. And as a result, what did you do to finish it up, Jack?
I used the equal property of 0. I just split it up into 2 equations equaling 0.
Yeah, exactly, right? So 0 product property, we know that we can split up our factors now that they are factored into 2 separate equations equal to 0. So x plus 2 is equal to 0, x minus 2 is equal to 0, and we end up with x is equal to negative 2, x is equal to positive 2. So our final solution set is x is equal to plus or minus 2. And once again, if you wrote it if you in your solution set, if you wrote x is equal to negative 2 and then comma positive 2, totally fine. I just save space. But yeah, great job. Any questions on this? Again, the real linchpin to this one is that you understand that, oh yeah, since we have a 0 on the right-hand side, there's only going to be one case because positive and negative 0 are the same thing. It's just 0. So you just drop the absolute values, you solve for your variable. It's just a normal quadratic that we've been dealing with for a little bit now. And once you factored it, plus or minus 2. So that was really the only one that I wanted to go over in particular today. Does anybody else have any other questions? Otherwise, I have no problem ending class a little bit earlier today, but I really want to make sure that everybody understands exactly what's going on with all of these problems, because for almost every problem, the only one being the exception was 25, you're following a very rigid, very formulaic process, right? Like you pick one side, and that side is going to be the side with the absolute value. If you have 2 absolute values, you just pick one, you keep it positive, and then you have 2 cases, one where the other side is positive and one where that same side is negative. And then you just solve and you test both of your solutions, and then if they work, great. If they don't work, they don't work. But that's, in general, what you're doing for all of these problems. Okay, so because nobody's throwing any other questions at me, I'm going to go ahead and assume that we all understand this. So we are going to end class just a little bit early today, 15 minutes, you guys get back to your lives. So go enjoy that. Sophia, if you could just go ahead and hang around for me, that'd be perfect. But yeah, everybody else, go ahead and enjoy your day. The next lecture will be up later today. And keep in mind that you will have a quiz on Friday. And next Friday is your midterm, right? It's office hours today. If you guys have problems, come to my office hours either today, next Monday, or next Wednesday. So otherwise, have a good one, guys. I will talk to you later.
Thank you.
Thank you.